Hi, good morning, everyone. I am Nicole Testa-Boston, the Deputy Director of the Fiatech Consortium. And on behalf of all of us at Fiatech, I want to thank you for joining us today. We have an exciting hour set aside to discuss next-level hospital planning. This group with the Deveni Group and DPR Construction was awarded one of our study awards at our gala this past April. And as we're doing with all the recipients, we're scheduling an hour to go into a little more detail on the achievements and innovations that were applied during their project. But before we get started, I wanted to just share with all of you some information on how to use the GoToMeeting tool, especially if this is your first time attending one of our webinars. You'll notice on your screen you have a toolbar that is unique to you. So you can move it, or you can minimize it, or get it off your screen, or keep it up. It's up to you. No one else can see that. You use the orange arrow at the top to minimize, and then click on that also then to maximize it. You'll also have noticed that you are on a default mute setting due to the number of attendees on the webinars. So instead of being able to speak, we ask that if you do have any questions or comments or would like to seek further clarification, please do use the questions tab on that toolbar. You can type those in at any time during the presentation. Those will go directly to me. And as time permits at the end of the webinar, I will field those questions to Peter and Eric, and they will answer those. If we do run out of time, we'll follow up with you after the webinar. I will not use your name or your company when fielding those questions, so please feel free, by all means, to seek any clarifications or more information using that tool. Lastly, we will be recording this session, both audio and visuals, and we will post those in our archives at fiatech.org. Usually takes a few days for us to package it up and post it on Blip TV, which we run an RSS feed to our website. So if there's others that you want to share this information with or download it, you'll be able to do that following the webinar later this week. So with that, I want to go ahead and introduce our two speakers today. Eric Ubersachs works for Deveni Group Architects, specializing in healthcare design, and is the project manager and project architect on the Sutter Health Alta Bates Summit Medical Center's new patient care pavilion. He's been working on this unique project for over 3 years, overseeing the design and construction documents through the often complex and intense OSHPD process, which he will explain during his presentation. Now that the project is well into construction, Eric continues to contribute to managing the process of commitments and submittals. Joining Eric is Peter Lockett. He is with DPR Construction and which is a mechanical cluster lead for DPR Construction, specializing in healthcare and integrated project delivery projects. Peter has been working on the Alta Bates Summit Medical Center's Patient Care Pavilion for the last 2 years, and his focus has been on design management, integrating the model and planning process from the building envelope to MEP coordination. So thank you both, Peter and Eric, for joining us today to share your story with our members, and at this point I'll turn it over to you.
All right. Thanks a lot, Nicole. We'll just dive in. Like Nicole said, I'm Eric Ubersachs, working with the Deveni Group, and have been working on the Alta Bates Summit Medical Center for the past 3 years. I wanted to give everybody a real quick overview on what the project is and where it is. It's in Oakland, California, and with all healthcare projects in California, our municipality that approves the drawings and runs through all the drawing review is called OSHPD. It's a very thorough organization for those of you that haven't done healthcare work in California. It can be a timely and intense process. So we're working through that. We're almost complete with that process as far as permitting is concerned. We went through the phase review process, meaning that we broke our building out into 3 different increments: a structural increment, a core and shell increment, and basically a tenant improvement or a TI increment. So we've gotten the first 2 permitted, and we're approximately a month or 2 away from getting the 3rd. So with that said, this is our building. If you can see my arrow here, located kind of just outside the heart of Oakland on an area called Pill Hill. It's got beautiful views of the San Francisco Bay. San Francisco is off on the horizon here, as well as the Berkeley Hills to the north, and obviously Oakland City directly to the south. So again, our building is located right here. We're located on an existing medical campus. Sutter Health has a fairly large facility here, which we are tying into due to seismic regulations. Their existing facility will be decommissioned in the near future, which was the driver for this project. California passed a Senate bill several years ago mandating that all buildings be seismically upgraded to meet current codes. So that's really the driver behind the patient care pavilion here. It's approximately, well, it's 13 stories, 11 above grade, 2 below grade. It was designed to be an icon or a new front door to the campus. It houses approximately 240 patient beds, as well as several services. The existing operating rooms will remain in the seismically compliant section of the existing building. So it's really a bed tower. You can see here in blue is the patient care pavilion and how it ties into the existing facility. There was a lot of attention that had to be paid to the proximity of our building to be able to maintain operation of the current hospital while under construction. At points we're as close as 6 inches away from existing foundations of an operating acute care hospital. So there's obviously a lot of things that needed to be considered from a logistics standpoint for both construction as well as design. Since we are tying into an existing facility, we needed to make sure our floor-to-floor heights were matching up, which caused some complications throughout the process. We're approximately 12'9" from floor to floor, and a lot of height, a lot of stories, which is really tight for an acute care hospital in getting all of the systems to work above ceiling and below structure. So that was one of the early challenges that we've been facing throughout the process. This is just a concept rendering of the initial patient rooms. This is the actual view from the rooms out into the bay. So really sleek looking. This is one of the places I'd like to be sick at, obviously. But just a couple more views of what we were planning for the hospital itself. This is a shot of the lobby, main entry into the hospital. Again, a lot of warm materials, inviting into the area. A typical nurse station. We have these obviously every floor, every patient unit has either 1 or 2, depending on the floor that you're on. Our elevator lobbies, and our family waiting rooms as well. Again, trying to utilize views of the bay as well as the Berkeley Hills. And again, this is just one last shot of some of taken directly from our model and incorporating some of the systems into the building at this point. So we started design of the project back in December of 2007. like I said, we're real close to getting our last permit. Designs officially wrapped up, but there are a few loose ends that we're tying up right now, getting through the permit process. We had to demolish an existing 6-story dormitory building that was on site. You can see in the lower left image here, we had to reroute the existing fresh air intake for the hospital so that it could be maintained during construction, so that all the operating rooms and other facilities within the existing building could be operational. There was some asbestos on site through demolition that was abated and removed. We finished demolition in December of 2010 and have started official construction. We're pouring concrete right now for our mat slabs. Some massive pours of 900 yards of concrete for a single pour, with some interesting characteristics to that, meaning that because of the thickness of the concrete, OSHPD was concerned that we would exceed the heat limit during the curing process and consequently have micro fissures in the concrete, reducing the overall strength of that. So we're having to mix approximately 70 pounds of ice per yard of concrete to maintain a cool enough temperature, as well as using thermal blankets to regulate the heat so it doesn't cure too quickly. So there's a lot of little processes that we hadn't anticipated that we're working through as well. We anticipate being complete by January 2014 with the new facility to turn over the keys to the owner for moving in. This is just a list. This is an IPD, meaning Integrated Project Delivery Process. We have an integrated form of agreement, which is the IFOA team. This is a single contract between 12 different parties that are all equal partners within this process. We all have what I like to call skin in the game, meaning there's a shared profit pool where we have all put a certain percentage of our profit at risk for this project, meaning that we all have incentive to make this project come in on time and under budget, or else our profit could be at risk in this project. The interesting thing here with who all is involved from an architectural standpoint, I think, is that we actually have more contractors than designers for part of this agreement, meaning that the people actually installing this work are involved in the design process and have a lot of say as well as a lot of input, giving us kind of this unprecedented body of knowledge through the design process, which has been extremely helpful and added a lot of value to the project.
I would also echo the fact that it's the IFOA is a real catalyst for causing team members to be proactive in their coordination effort and really drilling down to the root cause of many coordination issues that we struggle with.
Good point. This is the rest of the team, meaning that these I didn't list the individual companies at this point because there's so many of them, but these are all the different companies or different consultants that have been on board with this project during the design process. So again, it's this unprecedented body of knowledge that's brought early on into the project. We've got a lot of input very early on, which has been very helpful. This is just a quick map of where everybody is located geographically. We do all meet in Oakland, regularly in our big room meetings out here, which is now part of the construction trailers. Not every team member is in every big room meeting. We use a lot of technology as well, as far as smartboard technologies, WebEx, GoToMeetings, which is also very, very helpful. But we found that obviously the closer we can be, the more collaboration we seem to be able to get. You know, if everybody's face to face, it seems to just be that much more collaborative. This is just a group shot over the past 3 years. You know, we've all become a very, you know, almost a family. You know, we have a lot of good times. We have our challenges as well, where, you know, we don't always love our family, but we get through it all. So it's been a very rewarding process with everybody involved.
This is a list of software that we're using in order to generate our design documents. So this goes, you know, the full spectrum from architectural design all the way to the shop drawings and coordination level, in which we're doing with our MEP systems and XWall systems. And the idea is taking the coordinated model and flattening those documents, getting the designers and engineers and mechanical engineers of record to stamp the drawings and provide annotations prior to going into permitting. And so this is just a short list of some of the technologies we're using. So looking at the project process, we've been utilizing what we call a big room, and a big room is not only a physical description of the room, but also kind of the environment and process in which we've been living in for the last 3 years here, which vacillates between large team meetings to focus group meetings addressing planning and modeling and coordination concerns. If you look at the top left image here, this is just a snapshot from one of our big room meetings recently, and splintering off into pool planning sessions, which can be seen here, here, and here, that really surround efforts in coordinating increments that go into OSHPOD. And these increments, for example, increment 1 is our structural increment that shows deep foundations and building steel structure. Increment 2 covers basically the building envelope, and increment 3 is the interior systems and design, encompassing all the MEP systems as well. So within all those efforts, we pull back from our design deliverable, using separating each task and linking it appropriately to the tasks that it constrains, and figuring out as a team what our plan and path forward is, so we can correctly communicate our deliverable date to the permitting agency so they can plan accordingly for staffing and review. And what's been great is that we'll be able to splinter off into some of these meetings and really understand and come to the root cause of the concern for an issue. And you know, there's a lot of times where we come across major delays because we've come across new coordination items that have just surfaced. But the idea is to really understand these as a team and work together as a team as to how we're going to you know, address this issue and overcome any obstacle that's a rock in the road on the way to OSHPOD.
Right. So for those that aren't familiar with the process mapping process, we get everybody that has a deliverable or a task to get to a deliverable in the same room, and kind of work backwards from a submittal or a certain task. You know, as an architect, I may not know everything, or I do not know, I can tell you that, everything that is necessary in a mechanical package. So we have everybody involved which identifies constraints for them to be able to complete their work. In other words, what do I need to give you as an architect in order to finish your mechanical design? And from that, we'll be able to identify what the real critical path is and whether or not there's any schedule delays anticipated, in which then we will replan the work in order to get back on schedule. So it's everybody committing to giving another team member information that is needed to complete their task. So everybody's committing to something, and then that's tracked on a, we have conference calls every other day to just go through all of these plans and make sure that everybody has what they need and the work is flowing efficiently so that they can complete their work.
And the whole reason we spend so much time planning is that we want to increase our level of predictability for not only our deliverables, but in terms of the issues that we're trying to resolve and team focus. It covers a broad spectrum from everything from project burn rate to really focusing at the task at hand and making sure we meet our deliverables. So it's been a tremendous effort that's really brought our group together.
Right. Some of the two other images in each corner here are some of our constructability reviews. What's interesting here is that it's the actual project foreman, the guys that are going to be installing the work, involved in the modeling effort, reviewing how things are going to be installed, and making sure that the design team then gets that information translated into the 2D documents, which will be permitted. So we have input from the field, how they want to be installing the work actually permitted in our drawings.
And looking at this bottom left image, this is reviewing a coordination area of focus that we broke out for in one of our big room meetings. And having the model is a tremendous advantage because it brings this level of transparency to the design process, where issues can be virtually captured in almost a physical sense and can be reviewed as a team very quickly. And even with many different companies involved in this large process, we're all able to see the same body of work in real time.
Right. The last thing I want to touch on in this slide is modeling for fabrication. Because we have everybody involved in the design process, what we've done is, rather than the architect supplying the details from our typical wall section, we'll go to our building section and then key our details of, for example, the exterior wall system or the curtain wall. Within our permitted set of documents, we have over 800 drawings or 800 sheets of shop drawings of just the X-wall system, the X-wall and the curtain wall system. So we've brought the experts on board who know how they're going to install it early on in the process to be incorporated into the permitted drawings, which then allows us to both eliminate any deferred approvals that we may have, as well as the lengthy shop drawing review early or during construction. So everything's been coordinated in the 3D model prior to any construction. So there is no shop drawing review for the X-wall or curtain wall. We've done similar with the elevators, the vertical transportation, the stairs as well. So all of that information is already coordinated, and come construction of those elements, it's already been reviewed.
So here are some images of or extracted from the model, and just showing you some of the basic structures in which we encountered. And we at the top left here, we're showing building steel with all the concrete concrete decks and also deep foundations. Next image is of just the dynamic systems within the building, all the MEP systems, and then looking at the building exterior and envelope. These bottom images really show some of the complex level of coordination that we went through, and just the amount of information that's in this model that's got 97 million surfaces at the moment, and not only coordinating all the MEP systems, but what's not shown here is all the associated hanger location and seismic bracing location coordination that is then shown down to where the inserts would go for those hangers and areas of influence with halos, so we can lay out all of those deck inserts using a Trimble system to increase efficiency and also accuracy of our installation. And it's really resulted not only in a more productive construction plan, but also a more productive model and building to construct due to the amount of knowledge and constructability that we've been able to insert within the design.
Yeah, so there was a lot of discussion on what we should model, what we shouldn't model, what is kind of too much to get involved in. We're fortunate from Davini as well as BPR. We have a sister project down the street here as well with a lot of other IFOA team members being similar from team to team. The other project's about 18 months ahead of schedule from our project. And we were able to learn a lot of lessons from pitfalls and successes that they had. So, a lot of information on kind of, where is the value in modeling versus, what is too much. So we were fortunate to have that information as well. There is a difference, I think, between a lot of the interior and exterior modeling. Typically, the X-wall system is not modeled to the level that we brought it, and we'll talk about that in a little bit and some of the value I think we gained from that. So, there's a tremendous amount of square footage in this building. It's about 260,000 square feet. A lot to kind of coordinate. So what we did is we broke it up into similar programs, meaning, levels 5 through 10 are really just copies of each other. They're patient floors. Level 3 and 4 are very similar. And we broke it into chunks, much more manageable chunks to kind of get to this goal of a clash-free model.
So at the beginning of this process, we agreed to a trade clearance matrix, and this is just looking at our MEP systems here, but this is there's really two key points to take away, and that trades need room to install this work when they're out in the field, and also that the model is only as good as the accuracy of the installation. So if we're not making realistic commitments in terms of what the clearances should be, then it's not gonna work well physically in the field.
Right. So this is the matrix that we use to establish parameters for our clash detection. If something was within an inch of, if you look top right or left here, the fire sprinkler piping and the medium pressure supply, then it would report a clash. So what we had is we had all of the individuals that were going to be installing this work informing this matrix. So
looking at our coordination effort, this is a snapshot of a coordination effort during one of our chunks, and we typically try to address a chunk per week and measure ourselves within that range. And within this group, we resolved over 24,000 clashes, as you can see in these 8 days, as a team, and you can see the individual breakdowns of how that worked out on the right here. And the whole idea is that we will trend to zero, and some days make bigger leaps and bounds than others. But ultimately, the structure of these meetings would be that we'd be in the big room and basically have all the modelers sitting next to each other with a designer. That would either be a mechanical engineer or having an architect in the room as well if walls needed to move, and also addressing any cross coordination that would happen with more than 2 or 3 trades. And the idea is that these guys start off with a clash report in the morning, understanding all the areas in which they need to focus on and what specific issues they have to address, work with each other, go and have breakout meetings as needed to address certain issues, and then close the day with that clash report to measure our progress. And as this process moved down the road, and as we became much more of a well-oiled machine, the agenda became much more loose in the sense that we would still hit our production rates, but the team was so used to working together that just getting them in a room and starting this process with the end goal in mind and how we were going to measure ourselves per day was basically the new rollout and process in which we interacted by.
Right. So as Peter said, we broke each floor out, basically a week-long coordination effort where Monday we'd start with 8,000 clashes. That number's a little inflated just by the way the clash report runs. We typically find if you divide that by a factor of 4 or 5, that's more realistic of the number of clashes you have to deal with. And so the first time we did this, we got down to approximately 0 clashes. We had sign off. We were all feeling real good about ourselves. And then we took a step back and we took a look at it. And our model was reporting that we're clash free, but when we really looked at specific locations, you can see this duct run has 3 offsets in here. Is that really how we want to build it? We found that we were too focused on individual clashes and we're missing the big picture. So what we needed to do is we took a step back and said, okay, we really need to have the individuals that are going to be installing in this conversation, in these clash weeks as well, going over and looking at the clashes and understanding why something's clashing and what may be a better solution. So this is the same area, same snapshot, and in this kind of pinkish color is that same duct run with 0 offsets now, provided with the input from the trades as well. So we found that we really needed everybody involved in order to make this a success.
Yeah, building in constructability is a priceless effort, and it's really what's one of the most important things in the end game, to understand not just that it will be clash free, but that it's going in the way that we want it to, because these pieces of duct, for example, and most of our MEP systems come straight from an automated fabrication system. Like these pieces of duct will come straight from Utah on a truck, right out of the plasma cutter, straight from the program in which they're coordinated in. So we need to get them in the right shape so we can put them in productively.
So we did this for all 13 floors, obviously prior to submitting for our permit, so that we all had a good high level of confidence that we weren't going to run into any major coordination items out in the field. I want to touch on kind of some of the exterior coordination that we went through too. We decided that there'd be some value, we didn't know how much value, in modeling the exterior skin as well, and some of the components which tie into that. From an architectural standpoint, this isn't something that we would typically do, but because our installer or fabricator for the curtain wall wasn't 3D capable at the time, we took on this effort. And for this example, what we'll talk about is about 100 hours, which we went kind of above and beyond our typical modeling effort, which at a modeler's hourly rate of $100, came to about a $10,000 effort.
So to build this this level of accuracy into the architectural design model, and this is a $14 million exterior skin system. The way we attacked the building in terms of coordinating it was there's the architectural design model, and then there's also two separate building systems, the X-wall system on the front, which is a unitized system, curtain wall system, and then on the back side we have a unistack system. And both of those systems have shop drawings that are part of the OSHPD set, which need to be coordinated with the architectural design intent. So we started with confirming that the architectural design intent, since that was our baseline, was 100% coordinated in the fashion that we wanted it to be, so we could compare the shop drawings to the base intent. And within that exercise, we found tremendous value. And at a point halfway through coordination, we were at 4,000 clashes that we had found and also addressed. And we did a small study looking at the 16 top clashes from that group of 4,000, and broke those 16 clashes into 5 different categories to measure the return on investment. And right now we're yielding about greater than $1.2 million in return on investment. And these are clashes that we would have not found had it not been utilizing the 3D coordination process. And to just jump between a couple slides here, this is the breakdown of the top 16 clashes that we found. And what we did is we put a cost to each clash, going through the scenario of how this would have fared out with the coordination with OSHPD, further permitting, how it would have affected our construction schedule, and the cost to re-coordinate, and what the possible fix for this work would have been. We went through this with our designers and also estimators to quantify what these costs were. And just to talk about some of the coordination that we did between these systems, we were looking at the five different clash categories. We broke it down into half anchors versus steel and MEP. And so half anchors for the X-wall system are the embeds in the edge of slab that look like pitchforks that support the tube steel that holds up the exterior wall system. And when you have a clash between those two, the only thing is, even though you want to resolve it, you can't move the building steel, because we've already submitted to OSHPD in increment 1, and it's usually a column, which can't be moved anyway. And moving the halfin is very difficult, because that would change the alignment of all your different reveals and vertical assemblies on the exterior skin system. So it's really modifying the halfin anchor to fit that space. So it wasn't just an easy fix. It took several coordination meetings, new calculations, meeting with structural engineers, analyzing wind loads, and was a much more in-depth effort. Looking at a couple of the other systems we had here, we did curtain wall and storefront versus steel. And I know this sounds relatively basic, but there were some tremendously large dollar value clashes that we found. Looking at this central image here, there's 2 different elevation planes on this building, and it's this what we call the cut across the facade of the entrance, and there was a clash with the bottom of steel and the curtain wall mullion. And even though we had done a edge of slab coordination, and we were clash-free on that in a 2D world. When we brought it into 3D, we came up with this clash because the edge of slab coordination is always done off the top of steel elevations and not the bottom of steel elevations. And you can see we've got this diagonal cut going through the building that we anticipated we wouldn't have found until we came to install the curtain wall system, and the design and construction delays associated with this clash were very costly. So finding these levels of issues had really proven our net worth on return on investment. And looking at just a couple other systems, we looked at the X-wall system, which is the unistack system on the back side of the building versus steel, and it found similar issues where we found embedded steel within these panels that was an overlap that couldn't be the case because the two needed to be separate entities and one needed to support the other. And these are, finding structural elements that are buried inside your exterior wall that cannot be installed this way wouldn't have been something that you would have found by looking through the model. It's really being able to understand the different systems within the filing or within the BIM to make sure that they're not interacting, and that's really what we were testing.
Right. I just want to reiterate. I mean, these are things that we would have never found in a 2D world. We can cut as many sections as we want, in a 2D world here, and these clashes just would not have been found. So it's easy to really justify, on a $10,000 investment, we're close to $1.3 million on just 16 of these clashes. So there's tremendous value in this effort. Although there's additional design time involved, the savings through construction are proving themselves now. Yeah, just kind of summarizing some of the lessons that we've learned through here. I won't necessarily go through all of these. One thing that we found very important is that all partners need to be 3D capable. We talked about the extra modeling effort that we took on that typically an architect wouldn't do. If we can have the experts that are going to be installing this work or experts in that field modeling it, then there's just even more value to that.
And then also understanding that even though we're doing such a high level of coordination within the industry, not just at this project, utilizing modeling capabilities, it's important to understand that we're permitted and built from 2D drawings. The inspectors with OSHPD will only look at the 2D permitted drawings, and it's important to understand that the information that is within the model gets into the drawing level, and making sure that cross-coordination is done, because we're only allowed to install what's on the 2D drawings.
Exactly.
And then just following up on some of this planning process, it's really had to do with the fact that our architect and our other team members and IFOA members make the effort to come and really co-locate with us here on site in this large trailer complex we have within this big room. And the close location really equals closer collaboration.
Mm-hmm. Yep. I wanted to leave some time for some questions here. There's a couple links on here for some of the fun videos that have been going on. Demolition time lapse. We're doing some 4D scheduling based on the model, where we're modeling components with construction installed elements against time, as well as some basic project fly-through. But with that, I just wanted to kind of, I guess, open it up to any questions as well.
Thank you. Thank you very much, Peter and Eric. And yes, we have quite a few questions. So I will say, too, some of these questions, you know, maybe something we want to take offline. So if that's the case and it's going to be too detailed, just let us know, and we can defer those till after the webinar. One question that has come in about the slides. Yes, the slides will be made available. We are recording the session, and we will post it at fiatech.org in the next couple of days. Give us a few days to package it up and post it, but we will have that available. Question, what will be the final deliverable to the owner from a model standpoint? Will it be an as-built, and if so, in what format?
Yes, it will be an as-built throughout construction. You know, if there's changes that need to occur, the team is updating the model so that, again, we can submit those changes to the permitting agency. The final deliverable, you know, it's right now it's this, you know, a bunch of, I don't want to call them disjointed models, but a bunch of separate models which are able to be joined through programs like Navisworks and the likes.
Okay. How were the nurse stations shown previously been designed? Or how had they been designed previously?
Previously is compared, I'm not sure.
Maybe you know, is there something unique about the central location?
Yeah, there's nothing, you know, tremendously unique about the nurse stations in this building. They're centrally located on the unit so that they have easy access to all the patient rooms. You know, they seat approximately, you know, 3 people depending on where you're at. What is a little more unique is that we have all of the charting we anticipate to be within the patient room. All the patient rooms are private rooms, so we have computers and charting within the patient room so that the nurse station isn't your typical congested area where everybody's congregating to try to finish their work. So we have a lot of alcoves either in the corridor for additional charting, as well as, you know, hopefully the users really want to push bedside charting.
Great. And then I guess a follow-up from that last question before this one. She's asking who updates the model throughout the construction, the architectural model to as-built?
It's really, you know, it's who is responsible for that work. So any wall changes, the architect, meaning our guys back in our office, will update. You know, if it's a mechanical change, the mechanical engineer will update the model.
And it's important, people would not be updating the model if it was not part of their contractual agreement and part of the agreement in which we've come to with our owner for delivering a coordinated model, not only for permit, but at the end of the project as an as-built.
Thanks. Were there any client changes to the brief business in the design period? If so, did you already have strategies to cope with potential changes? Is there system separation between base, wall, et cetera, to allow independent changes of the elements?
There have been a lot of, there's been some significant changes through the process, design changes. You know, anytime that a new department head comes on board, you know, it's been a long 3-year process. If everybody has new ideas, so you know, managing those expectations has been challenging at times. But you know, since the team is always on board, we're able to discuss these changes really early on and understand what those implications are, and then be able to report back to the owner. You know, we're happy to make these changes, but these are the implications that it's going to affect. Whether it's a budget thing or a schedule thing, you know, by having everybody involved, we're able to report back very quickly as far as what this affects. And then the owner makes the ultimate decision on yes, we want to do these changes, or no, it's too late or too costly to do.
Thanks. Question, what milestones are you keying in on for the pool planning sessions? And can you share some of the key pitfalls learned?
Sure. Originally, on the pool planning, we focused on our OSHPOD deliverables. When each increment would have to go in order to maintain the schedule. Now that we've gotten permit on 2 of our 3 increments, we're looking at some construction milestones, and what is the last responsible moment to have an answer back which will affect the pouring of a concrete slab, for example. Some of the pitfalls.
So it's before we talk about pitfalls, just understanding the difference between kind of end milestones and also intermediate milestones. Even though we might have a milestone for an OSHPOD deliverable for a certain increment 2 or 3 months out, in which we're in our pre-con planning effort, we'll also insert intermediate milestones to understand the amount of duration needed for basically repeated workflow. So when we go through our different programming efforts, coordination efforts for the different chunks, we know that we can lop off 8 to 10 days at a time in terms of those repeated coordination tasks, and so that allows us to understand on a shorter term level where we're going to be pulling back from, and also as pitfalls go, I guess we'd say that those are more lessons learned, and that when you first start this coordination effort and you start really measuring your plan % complete and grading yourself as a team, it's definitely a learning curve. We are able to do the planning process much more efficiently now than we were when we first started. There's definitely a lot of heartache to the amount of time it takes when you are going through this process at the beginning, but ultimately it's very clear in the end that we get a concise plan that everybody has team buy-in to, and it's not just a plan that somebody created that we're following. It's a team that it's a plan that we created as a team. So I'd have to say that the advantages definitely outweigh the disadvantages.
Right, I would agree.
Terrific. A couple more. Was the estimating updated weekly? Was the budget a challenge during this process?
The estimate was updated every 2 weeks, extracting quantities from the model, and we had a report out prior we had a report out every 2 weeks because we had a every other week big room, so we had an on week and an off week, and with that we would be doing the rapid estimating in order to understand where we were trending towards GMP, and that decisions that we would be making, the cost analysis would inform decisions that we needed to make in understanding whether we had money in the budget or how much we needed to reduce the budget by in order to come to a GMP value. And so this was about a 1.5 year process of going through these every 2 week estimates, and issues that came up, we would have a risk and opportunity log that we tracked all of the outstanding cost and design issues on, and to really understand what our exposures were and what the last responsible moments were in terms of making these decisions.
Right. I think building in California, there's always going to be, well, building healthcare especially in California, is always going to be challenging as far as the budget's concerned. If you're building under $1,000 a square foot, you're doing pretty good. There were challenges, and we set up tools. We didn't really talk a lot about target value design, but that's one of the mantras that this team really embraces. Target value design is, we're designing to a target where we're getting constant updates from both BPR and our other trades that we're trying to hit, rather than the budget being a result of the design. We're designing with the budget. So, you know, it's been challenging, and we have a lot of tools that, you know, I'd be happy to discuss offline as well with anyone interested to track these issues.
Okay. Final question, I think. I noticed there are clearances I noticed there are clearances set up for clash detection. Won't it be better to address these by model access clearances? Any challenges to model access clearances for MEP elements? Any examples? Thanks.
I'm afraid I don't necessarily understand the model access clearance. I'm assuming that you just mean the basic clearance around your system, which we were coordinating that within Navisworks clash detection model by picking the two entities we wanted to clash, and then deciding as whether we wanted a hard clash or what the clearance was we wanted between those two systems, which is the value that we got out of the matrix that was shown in one of the slides. And those clearances were really decided with not only the project managers from each company, but also their field foremen to confirm that that's a correct working clearance in which they wanted to operate and install within. Anything that infringed on that, whether we wanted a 2-inch clearance and we were only getting an 1.5 inches, we would address those clash by clash to understand whether we needed to hold that true 2-inch tolerance or not. Right.
Great. Well, thank you very much. It looks like we've come to the conclusion of the hour, and I want to thank everyone for spending the past 60 minutes with us. Be reminded that we have recorded the session, and we'll make it available in the archives on the Fiatech website the next few days. And I want to give a real big thanks to Peter and Eric for sharing this with us, as well as congratulating them on the SETI for scenario-based project planning that was awarded back in April. So thank you again, and have a great day, everyone.
Thank you.
Thanks, Nicole.
Bye-bye.